Let's remember how to identify a function. To start off, we have to remember what a function is. The definition of a function is every input has only one output. There's another way for us to think about that. As a reminder, input is referring to our x values, output is referring to our y values. So if every input has only one output, that means that our x value cannot repeat. Let's look at some representations. First, we're going to look at ordered pairs. The key when identifying functions is to make sure that no x value is repeated. So I'm going to start by identifying my x values. In an ordered pair, we know that our ordered pairs are listed x, comma, y. So I'm going to highlight my x values. I have x value of 3, x value of -2, x value of 3, and x value of -2, to which both values, 3 and -2, are repeating. Therefore, this set of ordered pairs are not a function. We would say that this is not a function because inputs -2 and 3 have more than one output. Let's look at our next example. I'm going to start by identifying my x values. I've got -2, +3, +1, and 0. None of the x values repeat. Therefore, this is a function. This is a function because every input has only one output. Let's look at our next examples. Here we have maps. As a reminder, with our maps, all of the x values are located on the left and all the y values are located on the right. We want to make sure that each x value is only being mapped to one y value. As you can see, 1 only goes to -1. 3 only goes to 4. 5 only goes to 4. 7 only goes to 6. Now, sometimes we get confused because our y value has more than one x value pointing towards it, but that's okay. All we care is that each of our x values are only being mapped to one y value. We don't really want to look at our y's. All we care is that each of our x values are only going to one number. So this is a function. It is a function because every input has only one output. Let's look at our next example. Again, x is on the left, y is on the right, but we only want to focus on our x values. I can see that 3 is being mapped to -2. 1 is being mapped to 0. However, here, input 0 is being mapped to more than one y value. Since our input 0 is going to more than one output, this is not a function because input 0 has more than one output. Finally, let's look at some graphical representations. To determine if a graph is a function or not, we use what we call the vertical line test. To do the vertical line test, all you need is a vertical line. We're going to use this vertical line to make sure that it never crosses our graph in more than one place at the same time. So I take my vertical line and I start passing it through my graph. And I see that at all times, it's never touching more than one point on the graph at the same time. That means that this graph is a function because it passes the vertical line test. Let's look at our second graph. This time, when I pass my line through the graph, I see that it's actually touching the graph in more than one place at the same time. That means that the input -4.5 has more than one output. And that's actually true for several x values, but we just need one example. So that was a reminder of how to determine if something is a function or not, given a set of ordered pairs, a map, or a graphical representation.